Okay, today we're going to take a look at the remaining three ways that triangles are congruent. And the first two are ASA and AAS congruence. An ASA congruence is angle side angle. If two angles and the included side of one triangle are congruent to two angles and the included side of the second triangle, then your triangles are congruent. And angle angle side is when you have two angles but a non-included side of one triangle are congruent to two angles and the corresponding non-included side of the second. The two triangles are congruent. I'll go ahead and pause the presentation at this point so that you can copy these down into your notes. Okay, the third way today that we're going to take a look at triangles being congruent is hypotenuse leg. Now, in order for hypotenuse leg congruence to happen, you have to have a right triangle. If the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of the second right triangle, then your two triangles are congruent. And again, we'll go ahead and press pause here, but the key thing that you do have to have is a right triangle in order for hypotenuse leg to work. Okay, so we'll go ahead and press pause, and you guys can copy this down into your notes. Okay, your big key that you're going to struggle with, and you've got to make sure to pay attention to when you're looking at ASA versus AAS congruence, is where the side is that's congruent. Okay, if you take a look at the top two triangles here that are highlighted in blue, you've got these two angle or sides here that are in between the two angles. So since this side here is between the two angles, this is ASA congruence. But on the bottom triangle, you'll notice that the side is across from one of the two angles. If I drew a line from here, I'd hit this side. Well, that means that this is angle side congruence because the side is not in between the two angles that happen to be congruent. Okay, so you got ASA on the top and AAS on the bottom. So when we take a look at the picture here for number one, we want to determine whether or not the triangles are congruent by ASA, AAS, or HL. Okay, well, we've got the two angles here at the bottom that are congruent. You've got the angles up here at the top that are congruent, and the side is in between them. So this is ASA congruence. But on number two, you only have one angle that's congruent, and it is across from one of the sides. Okay, it's across from KM. You also have these two sides here, KL and NM, that are congruent. This is not a congruent triangle because this is an example of angle side side. And we know that angle side side cannot be a congruence reason between two triangles. Okay, so we take a look at the triangles in the picture, and we want to determine whether or not the triangles are congruent. And you've got, in this picture, these two triangles here that are outlined in black. Okay, and you've got the vertical angles here at the center that have to be congruent. You've got this angle here that's congruent, and this side here that's marked off congruent also. So we've got two angles on one side, so that's enough for our triangles to be congruent. The question that we have is how are the triangles congruent? Okay, well, the side that we've got here is across from this angle. Okay, so that tells us that this is an example of angle sides congruence. For letter B, all three angles are marked off the same. But are any sides marked off? Okay, they're not. And when you only have all three angles the same, these two triangles are not necessarily congruent. They might be, but in order for that to happen, you have to know side lengths. Okay, and since we don't know side lengths, we can't tell whether those figures are congruent or not. And on our last one, you got the angles in each corner, here and here, the same. You got this corner, and then you got the shared side down the middle. How are those triangles congruent? Okay, it's angle side angle. Okay, ASA. And again, you're going to have to be able to identify the ones that are missing as you go through with some of these problems. Okay, so triangle congruence proofs with angles. Okay, we're going to start with the fact that BC is congruent to EC. And those two things are marked off already. Okay, we're also given that angle B is congruent to angle E. Now, one thing that you want to look for, especially when you're looking at ASA, AAS, is vertical angles. And the minute you see vertical angles, you want to go ahead and use those. Okay, so we've got vertical angles here at C. So angle BCA is congruent to angle ECD. Okay, and our reason for that is the vertical angles theorem. Now we've got two angles on one side congruent. The side is in between our angles, so triangle ABC is congruent to triangle DEC by SAS or ASA congruence. Okay, any questions on that one? So again, you're still looking for finding three parts of the triangle to be congruent. Today we're going to probably focus more on two angles and one side instead of two sides and one angle. All right, for this proof that we've got here, it can be done a couple different ways. Anytime that you've got the parallel lines, that kind of creates a whole issue with how the proofs are done. And not so much in how to do them, because you're going to be able to show that all three angles are the same. It's just going to be that different people are going to say it's ASA, different people will say AAS. We're also given in this picture that BD is congruent to BC. Now, depending upon how you label your angles, that's going to determine whether or not the triangles are congruent by ASA or AAS. I'm going to go ahead and use the vertical angles here at the center. So angle ABD is going to be congruent to angle EBC by the vertical angles theorem. All right, now, using the fact that your lines are parallel, you also have alternate interior angles that are congruent. And this will affect how the triangles are congruent. Okay, for example, if I said that angle D was congruent to angle C, okay, because my alternate interior angles are congruent, this will make my triangles congruent then by ASA. But if instead I used angle A being congruent to angle E for my same reason, that would instead change my triangle being congruent to AAS. So it depends upon which one you want to use as to how the triangles are congruent. As a result, depending upon which angle you chose to be congruent, okay, your fifth step will be that triangle ABD is congruent to triangle EBC. Okay, and the reason for that is whichever one your reason was for step 4, so it was either ASA or AAS. So just know that the proofs can be done multiple ways, especially when you've got parallel lines down one side. Okay, here's another example. This time we're given that angle G is congruent to angle B, and that is marked off. Our other piece is that CB is parallel to GA. Okay, and those are two segments there also. For my third step, I always go with the very first thing that I notice, which generally is going to be speaking is the reflexive property. So because I know I've got a shared side here, I know that segment AC is congruent to AC by the reflexive property, and that's the one that I use. Now, there's my side that's congruent. The key piece now, you know that you've got lines that are parallel, so you have to use alternate interior angles. But the alternate interior angle that you have is going to be created between the transversal and the side that's congruent. So angle GAC is going to be one of the angles, and the other one that's going to be congruent is up here at C, but it's angle BCA. Your catch to this is that you've got to be touching the parallel line. Okay, what's going to end up happening is it would be at a point where you would actually be able to eventually prove that the other two sides, BA and GC, are parallel as well. But that's a long, drawn-out process. But you've got to make sure that when you're using parallel lines to create alternate interior angles, that you use the angle that's touching both the transversal, which in this case is AC, as well as the parallel side. Now, the side that's congruent is across from B and G, so triangle GCA is congruent to triangle BAC, and my reason for that is AAS congruence. Any questions? Okay, in our diagram, we're given that angle S is congruent to angle U. We're also given that RS is congruent to VU. Okay, and those things are marked off. Okay, what else do you know to be congruent? Okay, angle STR is congruent to angle UTV because of the vertical angles theorem. When you mark those angles off, those are across from the two sides, UV and RT, that are congruent. Therefore, triangle RST is congruent to triangle VUT by AAS congruence. Now, this proof was a little bit different because it didn't have the given and proved piece up there, but it does tell you your given piece happens to be the parts that we started with. That these two parts we started with, and this is our proof statement over here that I underlined. Okay, so sometimes they can look a little bit different. Okay, but the key word is prove, and that's how you can go ahead and two columns, something like that. Our last one asks us to write a proof. The triangle WZY is congruent to triangle XZY. And what we're going to start with is the fact that WY is congruent to XZ. Okay, and that's given to us. Now, you may want to redraw the pictures over here in a little bit smaller so that you can see them. So here's WY and Z. And then our other picture is going to be backwards. So that's Z, Y, and X. Okay, and now you can see that you've got two pieces that are congruent. We're given that WZ is perpendicular to ZY, and you are given that XY is perpendicular to ZY. Now I'm going to kind of combine steps here a little bit on step 4. And what I'm going to state is that angle WZY and angle XYZ are right angles. And the reason for that is the definition of perpendicular lines. Now, here's the part that's kind of important. In the proofs that we've done previously, we've needed to state that those angles were congruent, but that's not necessarily true. Once you know that you've got right angles, now you can state that triangle WZY and triangle XYZ are right triangles. Because if they've got a right angle in them, they're a right triangle. And that is the definition of a right triangle. Okay, now, the other thing that's kind of important is that when you look at your original picture, you'll notice that ZY shows up in both parts of the triangle. So even though it's not necessarily seen when they're separated, you certainly have a shared side. So now, ZY is congruent to ZY by the reflexive property. And if you look at your picture now, okay, you've got a hypotenuse and a leg of a right triangle. And as a result, triangle WYZ is congruent to triangle XZY by the hypotenuse leg theorem, by hypotenuse leg congruence. You don't see a lot of hypotenuse leg proofs. They do exist. A lot of times you'll actually find it, you'll end up using sometimes side angle side instead with right triangles. But this is an example of a hypotenuse leg proof. And like I said, they're not really easy to find. So it's not something that you're going to use a ton of, but you will see them from time to time. Okay, at this point, we'll go ahead and pass out the worksheet for homework here for section 4.4.